A cosmic perspective. From pale blue dot to radiant city. From the vast expanse of space, our Earth appears as a fragile oasis, a pale blue dot cradling life. This tiny speck, suspended in the cosmic void, is our only home, a delicate cradle of biodiversity and human civilization. It is a reminder of our shared responsibility to protect and cherish this unique world. Yet imagine gazing upon our planet centuries from now. Picture a world transformed by the ingenuity and perseverance of countless generations. A world where humanity has not only survived but thrived, overcoming the challenges of our time to build a future of abundance and harmony. Envision a radiant city, pulsating with clean energy, a testament to humanity's mastery over the laws of the universe. Skyscrapers gleam with solar panels, wind turbines spin gracefully atop buildings, and streets are illuminated by the soft glow of sustainable energy sources. This city is a beacon of hope, a symbol of what we can achieve when we harness the power of science and technology for the greater good. This is the promise of a Type 1 civilization, a civilization capable of harnessing the energy output of an entire planet. Such a society would have the ability to control and utilize all forms of energy available on Earth, from solar and wind to geothermal and nuclear. It would be a world where energy scarcity is a thing of the past, and where the potential for innovation and progress is boundless. But such a future hinges on our understanding of a fundamental concept that governs the flow of energy in the cosmos: thermodynamics. This branch of physics, which deals with the principles of heat, work, and energy, is crucial to our ability to develop and implement advanced technologies. It is the foundation upon which our dreams of a sustainable and prosperous future are built. This field of physics, often perceived as daunting and complex, holds the keys to unlocking unprecedented technological advancements and propelling us towards a brighter future. By mastering the laws of thermodynamics, we can develop new ways to generate, store, and distribute energy more efficiently. We can create technologies that minimize waste and maximize output, paving the way for a world where clean energy is abundant and accessible to all. The journey to becoming a Type 1 civilization is not without its challenges. It requires a collective effort from scientists, engineers, policymakers, and citizens alike. It demands a commitment to education, research, and innovation. But most importantly, it calls for a shared vision of a better future, one where humanity lives in harmony with the planet and each other. As we stand on the brink of this new era, let us remember that the path to a radiant city begins with the choices we make today. By embracing sustainable practices, supporting clean energy initiatives, and fostering a culture of innovation, we can turn the vision of a Type 1 civilization into a reality. Together, we can transform our pale blue dot into a shining beacon of hope and progress for generations to come. The universe's rulebook unveiling the laws of thermodynamics. Imagine a book that holds the secrets to how everything in the universe works, from the smallest particles to the largest galaxies. This book is the laws of thermodynamics, a set of principles that govern the behavior of energy and matter in our universe. Think of thermodynamics as the universe's rulebook for energy. It dictates how energy transforms, transfers, and influences matter. These laws are not just abstract concepts, they are the foundation upon which much of modern science and technology is built. From the engines that power our cars to the processes that keep our bodies alive, thermodynamics is at the heart of it all. Let's explore its 4 fundamental laws. Each of these laws provides a unique insight into the nature of energy and matter, and together they form a comprehensive framework for understanding the physical world. The Zeroth Law. Imagine 2 spaceships, each in thermal equilibrium with the cosmic microwave background radiation. This background radiation is the afterglow of the Big Bang, a faint signal that fills the universe and provides a common reference point for temperature. The Zeroth Law states they are also in thermal equilibrium with each other. This might seem obvious, but it is a crucial principle that allows us to define temperature in a consistent way. Without the Zeroth Law, our understanding of temperature would be much more complicated. This law establishes the concept of temperature. Temperature is a measure of the average kinetic energy of the particles in a system, and the Zeroth Law ensures that we can compare temperatures in a meaningful way. The first law. Picture a spacecraft using fuel to propel itself forward. The energy stored in the fuel is converted into kinetic energy, which pushes the spacecraft through space. The first law, also known as the conservation of energy, states that energy cannot be created or destroyed, only converted from one form to another. This means that the total amount of energy in the universe remains constant, even as it changes form. The chemical energy stored in the fuel transforms into kinetic energy, propelling the spacecraft. This transformation is a perfect example of the first law in action, showing how energy can change form but never be lost. The second law. Imagine a satellite orbiting Earth. At first, its motion is smooth and predictable, but over time it begins to experience resistance from the thin atmosphere at the edge of space. Over time, its orbit decays due to atmospheric drag. This drag is a form of friction that gradually slows the satellite down, causing it to lose altitude and eventually re-enter the Earth's atmosphere. This illustrates the second law, which states that the entropy of a closed system always increases. Entropy is a measure of disorder or randomness, and the second law tells us that the natural tendency of the universe is to move towards greater disorder. Entropy is a measure of disorder or randomness. In the case of the satellite, its organized motion is gradually converted into random thermal energy, increasing the overall entropy of the system. The satellite's organized motion degrades into random thermal energy. This process is irreversible, meaning that once the energy has been dispersed as heat, it cannot be fully recovered. The third law. Envision trying to cool a spacecraft to absolute zero, the lowest possible temperature. Absolute zero is the point at which all molecular motion stops, and it represents the ultimate limit of cold. The third law states that achieving absolute zero is impossible, although we can get very close. As we approach absolute zero, the amount of energy required to remove additional heat increases dramatically, making it increasingly difficult to reach this theoretical limit. Understanding these laws is paramount to developing efficient energy sources, designing spacecraft, and even terraforming planets. By mastering the principles of thermodynamics, we can create technologies that harness energy more effectively, explore the far reaches of space, and perhaps one day transform other worlds into habitable environments. For instance, in the quest for sustainable energy, the first law guides us in converting energy from renewable sources like solar and wind into usable forms without losing any of it. The second law reminds us of the importance of efficiency, as every energy conversion process inevitably produces some waste heat. In spacecraft design, understanding the first and second laws helps engineers create propulsion systems that maximize energy use and minimize waste. The third law is crucial in developing advanced cooling systems that can operate in the extreme conditions of space. When it comes to terraforming planets, the laws of thermodynamics are essential in managing the energy flows required to create and maintain habitable environments. By controlling temperature, pressure, and chemical composition, we can potentially transform barren worlds into thriving ecosystems. As we continue to explore the cosmos, the laws of thermodynamics will remain our guiding principles. They are the keys to unlocking the mysteries of the universe and harnessing its vast energy resources. Whether we are building the next generation of spacecraft, developing new energy technologies, or seeking to understand the fundamental nature of reality, thermodynamics will always be at the core of our endeavors. So, the next time you see a rocket launch, feel the warmth of the sun, or marvel at the complexity of life, remember the laws of thermodynamics. They are the invisible threads that weave the fabric of our universe, guiding the dance of energy and matter that makes everything possible.